has moved from several instances observed to a general principle. The use of earned value management will make projects successful. Okay? I move from specific instances to a more general law. Okay? Well, another example in the sciences would be if I observe objects falling at a given speed. Can I measure that speed? Well, if you do that, you observe that the speed is always the same on Earth. Okay? There is a formula to get the speed of objects, and the speed is always the same, depending, of course, on the distance from which the object is dropped. Okay. So you can describe laws of falling objects, and it's general law. So you observe first a few objects, then from that you draw general law, and you try to see whether it works or not for all objects. Well, in fact, in the case of falling objects, it does. You just need a few objects, try out, a few instances, poof, by the process of induction, you get general law. And then you try to, again, we're going to see it's not enough. Empirical data in induction is the first process, but this is not the only thing you should be doing if you are a researcher. But it's possibly the most important one. Okay? The ability to abstract, to move from the specific to the general. If you're just telling me things that are just very specific, I'm not interested. Okay? If on the other hand you tell me things that are pretty broad meaning and I would say even impact, but if you're telling me things that are pretty broad meaning, it's more interesting that you just give me a bunch of specificities. Okay? So in research, you must tell things that will go beyond just what you've seen. Otherwise, just hands-on. There is an abstract theoretical element that must be there. Okay? And in a way, this is linked to the process of induction. Okay. Now again, we're going to see that this process of induction is also at the root of your research when you do your PhD. Okay, so when trying to explain what the patterns are produced, what forces or processes they underlie, then we have to go beyond the original empirical method and construct a theory. Okay. Theories are made up of concepts, abstract words that represent concrete phenomena. We're going to see more about that. A paradigm is a logical system that encompasses theories, concepts, models, procedures, and techniques. So there are a few keywords here. Beyond laws, in general, you put theories. Theories there are several laws in them. They articulate several laws, you have a theory. And above the theory, you have something called a paradigm. Now, a concept is something important. Okay, concept, abstract words that represent concrete phenomena are important. We are going to see the idea of a construct also, which is an intangible quality on which individual whatever differ. And we're also going to see something about operational definitions. But first, at this stage, I want you to understand the process of generalization, of induction. Okay, we observe, see things, and we try to generalize. Now, of course, in the process, as I've told you, we are going to make mistakes. Generalization is handy, it's useful, but it's also risky. In the process, we have a tendency to make mistakes. However, this is the first step of thinking and of doing research. This is the concept of induction. After that, there is another thing that should come. It's called the hypothetico-deductive method. After induction will come deduction. Okay. Testing theories, the hypothetico-deductive method. Now, I don't know if you know about, I think it was one of the three Greek guys, Socrates, Plato, and Aristotle. I'm not sure I pronounced correctly. Anyway, those were the three guys. And, they were all the teacher of, and Socrates came first. Then came Plato, and finally Aristotle. Aristotle, who wrote much more than all the others. And, what Aristotle thought, he thought that women had less teeth than men. That was his idea. He proved, by the use of logic, that women had less teeth than men. Now, obviously, he was not correct. Okay. Had he counted the number of teeth of his wife, he would have found that women had exactly the same number of teeth as men. Okay. Nonetheless, he thought this was correct. Now, Aristotle was a specialist of logic, but logic is not all. He needed, in fact, much more empirical work before he could assert such things. But he was pretty good at something called logic, and actually the logic that was developed in those days, called Aristotelian logic, has stayed with us over the last 2,000 years, even more. I think it was 2,500 years ago that they wrote all this. Now, what is the hypothetical deductive method? Once you have chosen a topic and become a theory, is to create operational definitions. We are going to see that when you deal with ideas and concepts, the key element, the building block of this, is what we call the definition. Okay, our definition can be operational, we're going to see what they are, or they can be more theoretical, more descriptive. Okay? Now we're going to concentrate more on operational definitions. Okay? Definitions, each time you think of a definition, you think of a dictionary. You open a dictionary and you find a definition. Right? So, well, when you do your research, we see that you have to identify keywords. You will have not only to do that, but you will also have to find the correct definition of those keywords, dictionaries, whatever. And then, after you've done that, you have to go beyond just dictionary definitions. We have to create what we call operational definitions. Okay? Operational. What are they? What are operational definitions? Well, in the case of heat, there's a concept of heat. Okay? Like we'll take an example in physics. And then there is the operational definition of the concept of heat, which would be, well, the temperature measured on a thermometer. On a thermometer, you have an operational definition of the concept of heat. Now, it's interesting to see that the concept of heat has been around for ever since men have been around. But the way heat is measured is pretty new, in fact. It's only a few centuries old now. 3 or 4 centuries old. Before that, people wouldn't even agree that temperature could be measured objectively. It's true. Huh? People say, well, your impression of cold is not the same as mine. You're cold when I'm not. So people could say this is some kind of subjective feeling. Until, of course, came someone with the concept of a thermometer. Now, this concept, the idea of operational definitions, is an idea that you can also find in project management. Well, I'm talking about project success. Okay, but what do you mean by project success? Well, then you give a dictionary definition of project success. Okay, good. Now, how you have to go one step further, and how do you actually measure project success? Then you have to come up with clear criteria to measure project success. Now, there are quantitative criteria, such as has the project been delivered on time, blah, 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 within budget, correct scope, proper quality, etc. Then you can start coming with an operational definition of project success. It's not enough just to say, well, yes, the project will be a success, or yes, it was a success. You have to go deeper than just talking about it. You have to actually come up with proper definitions. And so, in a way, we're becoming more analytical at this stage. Operational definitions are concrete representations of abstract theoretical concepts. There are heat, I told you about this. Okay, so when you have an operational definition of a concept, it's called a variable, a measurable entity that exhibits more than one level of value. We see that operational definitions, such as the concept of heat or the concept of project success, can be transformed into variables. For instance, well, the heat on my thermometer in degrees Celsius is this morning 15. Project success on my scale from 0 to 100 is 84. So we've replaced vague ideas, concepts in a way. Our concepts have to be abstract, but you can't work only with concepts when you do research. You have to deal with concrete representation of those concepts that are called operational definitions and which are measured by variables. Okay. So you notice that now we're starting to become much more analytical. At first we had ideas, we were generalizing, it was kind of easy, I would say, natural. Now we're going to go in less, not less friendly, but a harder path, the path that is going up. And now we have to become more analytical, more questioning, more critical in many ways. Okay. So it starts by being much more clear in terms of what we mean by the words we are using. That's something that you will have to do in the course of your research. You have to clarify your ideas. Okay. Yes, your question?
Yeah, I had a question regarding variables.
Yes.
When we have, for example, two variables, independent and dependent variables, do we need sub-variables to be measurable, or may we have just two relationships, two variables?
Okay, first you've used some interesting words, dependent, independent. I will have to explain what it means, what is a dependent, what is an independent. So in a way you anticipate on what we'll do on the third day. In fact, I will introduce this idea of a dependent, independent on the third day. Now, how many variables should you have? It all depends on what kind of research you are doing. We see that if you do experimental research, the idea here is to have as few variables as possible.
Two?
As few. Two, it would be good. Yeah. Then, if you start having more, it becomes a mess. Now, as you go into correlational research, already with correlational research, you can handle many more data. 10, 20, it's typical. And if you do more qualitative research, well, there is no limit. You can use just, okay, so it really depends on the kind of research you want to do. Now, the accuracy you will lose, here it's very accurate. In a way, you will, there's always a trade-off. You can never do something perfect. Okay. So that's why some people have a tendency to mix the research methods together, so they can benefit from the strengths of various approaches. Now, this is good. Personally, I'm an advocate of research, mixed research methods. The only problem is it will double the amount of work you will have to do, almost. So it's good. Personally, I'm very much in favor. It's just that it will increase the amount of work you will have to do. But again, it's entirely up to you to decide how much work you want to do. Okay. All right, so let me close the parenthesis here. And we will see, right now, let me get back to those words here, general words. Induction, so induction, generalizing. Then we're going to go into something that is more deductive. Now, let me continue. So, in a way, what I've introduced by getting ideas, etc., is what you do when you start your research. You start by getting ideas, reading things, I've seen this and that, you have ideas from your work. You get ideas, you're in a more creative phase, if I may say. Opening up, you try to find what's out there, you get ideas, etc. And then one day, you have to stop. End of the trip, end of the, it's nice to drift and take boats or planes to new countries of, trips and discoveries of new concepts and ideas. But one day you have to stop, you have to move into another phase of your research. And this other phase is a phase that will get you somewhere. Of course, the first one will get you to lots of places, but it won't lead you to your PhD. It will lead you to something else. In fact, some people, it leads them everywhere, but to their PhD. Yeah. They end up lost in the sea of knowledge, and they never reappear. They just drown, and you never see them again. So you have to one day to stop. It's like every trip. You cannot be an eternal wanderer, and one day you have to stop. So you stop precisely by becoming much more analytical, precise, rational, and of course we need both processes. We need both to be open up, to diverge, to be creative, but we also need to be analytical, critical, and precise. Okay. So then I was telling you about research. Of course, there's a big parenthesis relating what we've seen to the concept of the PhD, but let's try to look at this only from the point of view of what is research. Okay. So after the empirical inductive process, we move to the other one, the hypothetical deductive method. Create operational definition. Everything is much more clear. From the operational definition, we obtain variables, and then we get something called an hypothesis. Now, what is an hypothesis? Well, an hypothesis is a question. Many people say, yeah, well, what is the research question? What is the hypothesis? Well, an hypothesis is a question. Okay. An hypothesis, maybe Ralph has told you already, we relate at least two variables with each other. For instance, the use of earned value management will increase project success. Well, you have earned value management, project success. One will be the code, I will see how they are related.